Hello students, welcome to my YouTube channel RD Academy. Okay, so in this video we will continue with our study of electric fields and charges. Okay, so the section we are going to discuss in this video is section 1.6. Section name is Coulomb's law. Okay, so this is relatively a larger section, hence it will be of more duration, so please pay attention. Okay, so before studying what is Coulomb's law or the vector form of Coulomb's law, there are some prerequisites that you need to know beforehand. Okay, so the first prerequisite that you need to know is what is known as point charge. Okay, I'm sure you've heard of this word, but what exactly is a point charge? So point charge implies, so this is actually an approximation principle. Okay, suppose say you have a body. Okay, inside this body some amount of charge is present. Suppose say, let us say 1 coulomb charge is present. So what a point charge is so this charge of 1 coulomb is distributed on a sphere of radius, let us say 1 centimeter. Okay, so whenever you are dealing with the distances far greater than the radius of the object or the dimension of the object containing the charge, this whole charged body can be approximated to point charge. In the sense, this charge, there will be various electrons now to constitute this 1 coulomb charge. How many electrons should be present? Previously we have seen 6 into 10 power 28 electrons constitute this charge of 1 coulomb. Okay, so the charge will be present throughout this matter, but when you are dealing with the distances far greater than the dimension of the object, that is, for example, suppose say you are finding the magnitude of electric field due to this charged party of at a distance of 1 kilometer. So now this distance very larger, no, the dimension of the object is just 1 centimeter, whereas the distance at which you are measuring the force or field due to this charge is 1 kilometer. That is very much greater. So in this scenario, what you can do is you can reduce this charged body of 1 centimeter to a point charge. All the charges will be concentrated exactly at the center of this body. That is what this point charge is. So that is the first prerequisite that you need to know. What is the second prerequisite? Second prerequisite is triangle law of vector addition. Okay, so you have already learned this in your first year syllabus. Okay, so I will just briefly recap this triangular law. So what is triangular law of vector addition say? Suppose you have 3 vectors. Okay, so how will you find the add 2 vectors, not 3, sorry. Suppose assume you have 2 vectors, A vector and B vector. How will you add these 2 vectors? So the triangle law of vector addition tells you that you take the first vector, okay, you align it here. Okay, so this is the tail end of the first vector, this is the head end of the second vector. Okay, now take the second vector and align it with the first vector in such a way that the tail end of the second vector is exactly coinciding with the head end of the first vector. So the second vector is B vector. The tail of the B vector should be coincident with the head of the first vector, that is A vector. Okay, so when you do this process, the resultant of these 2 vectors, when you add these 2 vectors, A vector plus B vector, is obtained by a vector which is drawn from tail end of the first vector towards the head end of the second vector or last vector. So this particular line that I have drawn now, this represents resultant vector which is A vector plus B vector. Okay, so this is the triangle law of vector addition. So point charges and triangle law of vector addition, these are the prerequisites that you need to know to learn Coulomb's law. Okay, now without wasting time, we will jump into statement of Coulomb's law and its mathematical equation. Now the statement, see, while writing the statement of Coulomb's law, it is much easier to write it after knowing the equation. Okay, so I will tell you that. Now assume there are 2 point charges q1 and q2 separated by a distance r. Okay, I have not said whether it is positive or negative charge, it doesn't matter. Okay, even if it is positive or negative, it doesn't matter. What Coulomb's law tells you is that the electrostatic force of repulsion or attraction. Now go back to the first section. First section I have told you that if both of the charges are same, for example if both of them are plus, what happens? They will move away from each other, that is they repel each other. But if both are unlike charges, what happens? They will attract each other, that is they move towards each other. Okay, so now the electrostatic force between them is of two types. One is it can be force of attraction or it can be force of repulsion. Okay, so Coulomb's law tells you that the electrostatic force of attraction or repulsion between these two charges q1 and q2 separated by a distance r is, that electrostatic force of attraction or repulsion, I will represent it as F. That particular force is directly proportional to product of magnitude of charges. Okay, that is the first quantity. And it is also observed that particular electrostatic force of attraction or repulsion is inversely proportional to square of distance between the two charges. Okay, so now combine these two equations. You can write it as the electrostatic force of attraction or repulsion between two charges q1 and q2 separated by a distance r is directly proportional to product of magnitude of charges, and it is inversely proportional to square of distance between the two charges. Okay, this is what the statement of Coulomb's law tells you. Many students, what they make is they end the statement here only, that is inversely proportional to square of distance between them, but that is actually an incomplete statement of the Coulomb's law. There is one extra point. Okay, since force is a vector, it will have both magnitude and direction. The magnitude part, this has taken care of it. Okay, these q1 and q2 is number and r square is also number, so you have got the magnitude. What about its direction? That also you need to specify, no? So this electrostatic force of attraction or repulsion, the last line you have to write compulsorily is it always acts along line joining the two charges. Okay, this is one of the most important point, but students fail to write this in exam. Okay, so just make sure you have to write electrostatic force of attraction or repulsion is directly proportional to product of magnitude of charges, inversely proportional to square of distance between them, and last point you have to add is that this force always acts along the line joining two charges. So if you take this example here, this is the straight line, right, that is joining the two charges. So this force of attraction or repulsion between these two charges always lies on this straight line. If both of them are positive charges, what happens? They will repel. This vector will lie on this straight line. If one of them is negative charges, what happens? Still they will attract each other. This vector will act in this direction, but it should lie on this straight line between two charges. Okay, so this is what your Coulomb's law tells you. I will give you detailed notes, handwritten notes in the WhatsApp channel. So here just try to understand the concept. Okay, now you have introduced one proportionality symbol, right? So now we need to remove this proportionality symbol. So whenever you remove the proportionality symbol, you have to add one proportionality constant. That proportionality constant here is 1 divided by 4 pi epsilon naught. Okay, the remaining part remains the same, q1 q2 divided by r square. Okay, So in this proportionality constant, this 1 by 4 pi is numbers, but there is one special character here, that is epsilon naught. This epsilon naught is known as absolute permittivity of free space. Okay, with learning the first part of your textbook, you will get to know what is this epsilon naught. Okay, so for time being, just remember this name. Epsilon naught is called absolute permittivity of free space, and the value of epsilon naught is 8.854 into 10 power minus 12 Coulomb square per Newton per meter square. Okay, now 1 divided by 4 is constant, pi value is 3.14, and epsilon naught value is this much. So what happens if you substitute all those numbers? Then you will get this number 9 into 10 power 9. This part remains the same, q1 q2 by r square. So in problems, while solving problems, there is no need to write this term every time. Okay, you can directly substitute f is equal to 9 into 10 power 9. Fine. So this 9 into 10 power 9, it is represented by a symbol small k. 9 into 10 power 9, that is its value. What will be its unit? Now look at here, this k value, if I write this equation as f is equal to k into q1 q2 by r square, here retain the k on right hand side, transfer everything to left hand side. What happens then? K is equal to f r square by q1 into q2. Okay, so now write the units. What is the SI unit of force? Newton, and SI unit of distance is meter, but here you have square of distance, so it is Newton into meter square. In denominator you have SI unit of charge is Coulomb. Coulomb into Coulomb, you will have Coulomb square, but since this is in the denominator, when it comes to numerator you will get minus 2. Okay, so this is the brief explanation of Coulomb's law. Now, as I have said, this electrostatic force is a vector, right? So there is something known as vector form of Coulomb's law. Okay, this is also important. Now, to study vector form of Coulomb's law, consider this arrangement. Okay, assume you have a xy coordinate system. This point is origin, right? Now there are 2 point charges q1 and q2 situated somewhere in the xy plane. Okay, now let r1 vector be the position vector of the first charge q1. Similarly, r2 vector is the second position vector of the second charge q2. Fine. Now you already know that position vector is always drawn from the origin. So r1 vector is a position vector of charge q1, r2 vector is a position vector of charge q2. Now how will you find this distance between these two charges? How will you find it? Now it is similar to triangular law of vector addition, right? You have one vector a vector. If you draw another vector b vector in such a way that the tail end is coincident with the head end of the first vector, then the resultant is drawn from tail end of first vector to second vector. Okay, now can you write triangular law of vector addition for this triangle here, O q2 q1? Which is the first vector you have considered? This one, right? Assume this is the first vector you are taking. So this r1 vector plus, which is the second vector, this particular line that you have drawn is your second vector. Okay, so let us call this as r21 vector. So the sum of these two vectors must be equal to the third vector, that is r2 vector. Okay, now what will be r21 vector from this equation? R21 vector is equal to r2 vector minus r1 vector. Transfer this to the right hand side. Okay, now try to understand what is this r21. This r21 vector is the straight line, or it is the vector joining the charge q1 with q2. this line has a significance. As you remember previously, this force always acts along line joining the two charges, right? So now this r21 vector represents the direction of that particular line. Okay, so I hope this is clear. You just have to have a good understanding of triangular law of vector addition. Okay, now you already know what is the line join. Now try to write this equation, Coulomb's equation, in a vector form. Now we already know that electrostatic force is directly proportional to product of magnitude of charges and inversely proportional to square of distance between them. Now I am discussing only magnitude. That's why I did not write a vector sign here. If I draw one vector sign here, then I need to write one vector here also, because a vector can never be equal to scalar. A vector should always be equal to another vector. Now, what is the direction of this force? I have already told you, force always acts along the line joining the two charges. So, this particular force is acting along line joining the two charges. Which is the line joining two charges? This r21 vector is the line joining two charges. Okay, but while writing here, you cannot write the vector. You need to write the unit vector r21 cap. Okay, if you are writing vector, what happens? K q1 q2 divided by, you need to write r cube into r21 vector, and this equation is what is known as the vector form of the Coulomb's law. And this is most important for your MCQ, because they will ask this one: which of the following option represents vector Coulomb's law in vector form? Now why did I write the cube sign here as soon as I introduced the vector sign here? See, Coulomb told that it is inversely proportional to square of distance, right? Now if you write a vector, any vector, a vector, you can represent it as magnitude of a vector, that is an, multiplied by the direction. That direction is the unit direction. I will write it as n cap. Okay, it can be either x, y or z. So here I have written unit vector. That doesn't change anything. A unit vector is a vector with only one magnitude. Whenever you multiply this whole quantity with 1, nothing changes. Okay, but if you write the vector here, what happens? A vector is equal to magnitude multiplied by scalar. So this r21 vector is again equal to the magnitude r21, which is the distance between these two charges, that is r, multiplied by r21 cap, the direction from charge 2 to charge 1. Then this r21, this r will get cancelled. Again you will have r square in the denominator. So the vector form of Coulomb's law is F vector is equal to k into q1 into q2 divided by r cube into r21 vector. Okay, I will always tell my students, whenever you write the expression, you need to explain the terms. Okay, below this one you have to write where F vector represents electrostatic force of attraction or repulsion between charges. Q1 and Q2 are the point charges. R is the distance between the two charges, and R21 cap or R21 vector is the vector drawn from point charge Q1 to point charge Q2. Okay, now we need to understand why this number is given R21. Okay, now listen, this is point charge Q1, this is point charge Q2. Now each of this Q1 and Q2 can either be positive or negative, right? Now when can this product be greater than 0? When both of them are either positive, then positive into positive is greater than 0, or when both of them is negative, negative into negative is also greater than 0, because it becomes positive. That is, when Q1 and Q2 are like charges, then this Q1 into Q2 will be greater than 0. When Q1 and Q2 are unlike charges, what happens? That is, one of them is positive and another one is negative. Then their product will be less than 0. Okay. So now what happens? Take the first case. Now this is a straight line. joining between them. Okay, now you need to understand the notation of writing the forces. Now consider this force. This force Q2 will experience some force due to charge Q1, right? And assuming that they are like charges, that force will be in this direction, because plus and plus or minus and minus should repel, right? So that particular force is always written as F21 vector. So what does F21 indicate? Force acting on charge Q2 due to charge Q1. Okay, similarly, what will be the force acting on this charge? Charge is Q1, due to which other charge force is acting on it? Due to charge Q2. So here it will be F12 vector, and while reading you should read it as force acting on charge Q1 due to presence of charge Q2, and this charge will move in this direction, right? So this is the direction of F12 vector. Okay, now I have already told you here that this is the direction of R21 vector, that is, this is the direction of R21 vector. Now tell me, for like charges, how will you write the vector form of Coulomb's law? And for unlike charges, how will you write the vector form of Coulomb's law? For like charges, now you will write F vector is equal to K Q1 Q2 by R square. Now consider this case. What happens when they are like charges, either plus plus or minus minus? F21 vector, that is force acting on second charge Q2 due to charge Q1. Yeah, in which direction it is moving? It is moving in this direction. And which is that direction? It is same as this R21 direction. So I will write R21 cap, where this R21 cap is the unit vector in this particular direction. Okay, similarly, can you tell me what will be F12 vector? F12 vector will be same. Okay, the magnitude remains the same, it won't change, K Q1 Q2 by R square. But what will be its direction? Now look here, this F12 vector, that is force due on charge Q1 due to charge Q2, is moving in this direction. And which is that direction? It is in opposite direction to this R21 vector. So here you should write minus R21 cap. So now if you combine these two equations, you can write it as F21 vector is minus F12 vector. That is, both these force vectors have same magnitude, but the directions are opposite. Okay, so that is one important conclusion from Coulomb's law. Whenever you have charges, both the charges due to the presence of one another will experience same force, magnitude remains the same, but the direction will be opposite. If one moves in this direction, then the other will move in this particular direction. That is for like charges. Similarly, try to understand what will happen for unlike charges. I will just give a brief explanation here. For unlike charges, what happens? Now assume this is Q1, this is Q2. What do you mean unlike charges? One is positive, another one is negative. This distance is R. And which is the direction of R21 vector? This is the direction of R21 vector. Now, what happens if they are unlike charges? Tell me, there will be F21 vector and F12 vector, right? Now you should tell me the direction. Okay, now the force on this charge Q2 due to charge Q1 will be in which direction? In the opposite direction, right? Because this positive charge will pull the negative charge from this side to this side. So this is the direction of F21 vector. And what happens to this positive charge? This negative charge will pull the charge from this direction to this direction. So this F21 will act in this direction. So here also what happens when you write individually F12 and F21? Now what happens? F12 will be R21 cap. Okay, here you have this term and I don't have the space, so I'm not writing. Here you have this entire thing, but unit vector is now plus R21. Previously F21 it was plus R21. Here F12 is plus R21. What will be F21? It will be same magnitude but opposite direction. See, now F21 is moving in this direction, that is opposite to this R21. R21 is going from here to here, F21 is coming from here to here. So here also that equation is valid. F21 is equal to minus F12 vector. Okay, so this is the explanation for Coulomb's law, and this ends the discussion of section 1.6. So as I have told you previously in this section, the statement is important. That is an important 2 marks, or sometimes they can also ask for 3 marks question. This, it acts along the line joining two charges. Do not forget to write this point. It is the most important point. Okay, whenever you write equation, make sure you explain the terms. If they ask for vector form, this represents the vector form. Okay, if there is a vector sign here, the denominator should be cube. If there is a unit vector symbol here, then the denominator should be r square. This is most important for your MCQ. Okay, so I hope this video has been helpful for you. We will continue in the next video. Thank you so much.